All right, the plan for today is really to cover two main topics. One, a discussion of the slope of a line, and two, a quick review of how to graph lines on the graphing calculator. Uh, Again, I'm going to have the supplemental videos posted in the next day or so, so they should be up. I might actually push that homework back a week just to give you a little bit more time to work on that. Since I'm getting the supplemental videos posted a bit later in the week, that'll give you kind of a full week to work on that material. And before we jump into it, quote of the day for today is by chess grandmaster Daniel Naroditsky. Very entertaining guy to watch on YouTube, and very good at like the fast chess time controls. And one of the things, this isn't maybe a direct quote from him, but he kind of says some variant of this somewhat often, that there's a distinct difference between abstract and concrete advantages. So what does he mean by that? Well, in chess, that might mean something like maybe I'm ahead in development after the first 5 or 7 moves. I have more pieces out than my opponent does. So I have things like better attacking chances, or maybe my opponent brought his queen out and I attacked his queen twice. That let me get 2 pieces out while he's just moving his queen around. That's kind of an abstract advantage. If I rest on my laurels, if I sit around for a few more moves, my opponent gets all their pieces out and we're back to equal. So that's an abstract advantage. Versus, say, a concrete advantage, if I can turn an attack into on my opponent's queen into, say, winning one of their pieces, if I can capture their bishop because they had to sacrifice the bishop so they don't lose their queen, that's a concrete advantage. They don't have a bishop the rest of the game. So how does this kind of translate into real life? Well, think about, what you're doing right now. You're working towards a degree. You get a degree in a field, you get a credential. That's an abstract advantage that is something you can take to the job market and turn into, the career that you want, or a better salary, or the lifestyle that you want. But it kind of sits as an abstract advantage until you turn it into a concrete advantage. Right. Or maybe at the beginning of the week, plan out your time for that week. You say, okay, I'm going to study for these hours each of these days, and I'm going to, do fun things, hang out with friends for these other hours each of these days. That's an advantage, certainly, to have that planned out, but it's abstract until you actually implement it and it becomes concrete. So if you follow through with that plan, that implements it, that becomes a concrete advantage. You can take that plan and turn it into maybe better performance on an exam or better grades in your classes. So I think a lot of our decisions come down to, how do we convert abstract advantages into concrete advantages? How do we kind of play to the strong points of our hands, so to speak? Okay, so that's the thought of the day for today. So moving on, graphing linear equations into variables. We had one last example that I left as an exercise last time and said to kind of work through yourself. We're going to work through it by hand, and then we're going to look at how to work through it on the calculator. So let's take a look at this equation. Y plus 5 equals 2/3 x. And how do we approach this before? Well, we said, I need to find 2 points that I can graph the line through, but I'm going to actually find 3 points so that I have 2 points. I'll graph my line, and then I'll use my third point as a check to make sure that that third point looks like it's on that same line, and then I feel pretty confident that that's the correct line. So what can I use? Well, I suppose I could pick x equals 0. That gives me y plus 5 equals 0, so y then must be -5. I have 2 variables, 2 degrees of freedom, if we want to call them that, and one constraint that this equation must be satisfied. This relation between x and y must be satisfied. That leaves me with 1 degree of freedom. That leaves me with 1 free choice. But once I make that free choice, say if I set x equals 0, if I impose that on the system, then the equation tells me what y has to be. Similarly, maybe I look at, say, y equals 0. That tells me that 5 equals 2/3 x. Or I multiply both sides by 3/2, I get x equals 15/2. No, I mean, that's a perfectly fine point on the line. There's nothing inherently wrong with that point, but it's maybe going to be a little bit annoying to graph. Maybe I would rather choose not to use that one. That's fine. I'll just find two other points. I do notice that this 2/3 on the x is what's kind of causing the problem. It's kind of causing the fraction result over here. So maybe if I pick x to be multiples of 3, that will divide out that 3. So maybe if I pick x to be, say, 3, then I see that my equation says that y plus 5 equals, well, 2/3 times 3 is just 2. Subtract 5 from both sides, y equals -3. And then similarly, if I choose x to be, let's say, 6, the next multiple of 3 up to divide out that 3 on the bottom, I get y plus 5 equals 2/3 times 6. The 3's divide out and I get 4, or y is -1. So this gives me integer points that I can use. Again, nothing inherently wrong with 15/2 comma 0. It's going to be a point on the line as well, but it just might be a little more annoying to graph. Let me get a little bit of extra space here. And now we'll draw our axes. I see for x, I'm interested in 0, 3, and 6. And y, I'm interested in -5 up to -1. And I have 3 points, 0, comma -5. That's this point. 3, comma -3. That looks like that's about there. This would give me a line that looks something like that. And then 6, comma -1. That does seem to be on the line. If I had plotted my third point and it was up here, something somewhere went wrong. Either one of my 3 points, at least, I did something wrong. I don't think my artistic skills aren't excellent, but I don't think I'd be off by that much, right? But I don't see that. I see my third point looks like it's basically on the line. That serves as kind of a check and makes me confident that I have the right answer here. Now let's jump over to the calculator and see how we would approach this on the calculator. So we're using a graphing calculator. I'm using the TI-83 here. The TI-84 is extremely similar. You can use really any calculator that you want. I would recommend using the calculator that you plan to use on the exam, for your homework and working through the material in class, any of that. That way you just have practice using the calculator that you're going to use on the exam. So when you get to the exam, it's not a completely new feel. And keep in mind that really the only restriction on calculators that you can use on the exam is that your calculator can only be a calculator. So you can't use your phone as a calculator or like the Desmos website or something like that. So the calculator can only be a calculator. So any physical handheld, Texas Instruments calculator, Casio, HP, any of those kind of things, I would recommend a graphing calculator. But if you want to use calculator alongside a little 6-function handheld calculator, you're certainly welcome to do that. So I would recommend using the calculator setup you plan to use on the exam on all of your homeworks and in class and all of that. Okay, so we have the TI-83 brought up here, this emulator. If you're looking for an emulator to use in the meantime, if you're kind of working out getting a calculator, this Wabbit Emu, I didn't name it, but it's like WABBIT EMU calculator is a pretty good one. It's a pretty good emulator. you download the emulator, which is the software that runs a file that, knows what the calculator looks like and how it works. It's called a ROM file. And then you download a ROM that you can use to run on that emulator. And I mean, ideally, you would plug in your physical calculator into the computer and download the ROM off your physical calculator, but that's a little technologically annoying to do, let's say. So, if you download the ROM online, if you have access to the physical calculator, personally, I don't see a problem doing that. I don't know, there might be some legal technicality that that's not allowed, but I think at least morally and ethically, that's a reasonable thing to do. If you have the calculator, just saving yourself the hassle of trying to figure out how to get that calculator's ROM from the device onto your computer when you're dealing with a TI-83 that's, that was like, I don't know, feels like it was built around the time of the moon landing or something. Certainly doesn't have Bluetooth or Wi-Fi or any of that. So it's a little more just technologically challenging these days to get the ROM from the device onto the computer. Okay, all that being said, we come over here and we know that this calculator works like a normal calculator. 1 + 2, hit enter, there we go. But it has a lot of other functions as well. It has things like statistics functions. We're not going to use that, obviously. It has other mathematical operations. We're not going to use most of these operations. So most of what we have over here in the calculator, not really applicable to MAT108. The main thing that we're going to use this calculator for is, aside from just basic calculations, just it has the ability to do all of these basic add, subtract, multiply, divide kind of operations. We're going to use these 5 buttons at the very top of the section that has the buttons, right at the bottom of the screen here. It's actually its own little kind of section up here. The buttons say Y equals, window, zoom, trace, and graph. So we'll jump into the Y equals menu. Oops, I still have some stuff in here from before. When I hit Y equals, I should get a picture that looks like this. Now, just in case you hit Y equals and you got something that looks different, maybe you got, something like this or something. So I'll show you how to change it to kind of the standard settings. Once you change it one time to the standard settings, you should never have to change it again. If you bought a brand new calculator, it should be at the standard settings. But if you rented one or borrowed one or bought one used, it might have some funky settings in it. So to get everything kind of set up and ready to go, see where it says second here, the yellow button on the top left. Next to that says mode. So click on mode. And then basically we just want everything. You see that each of these categories, I can change these settings. And the one that's highlighted in dark is the one that's active. Basically, I just want all of the leftmost options to be highlighted. So I see that float, for instance, is highlighted. It's operating in floating point mode. So if you have 1 + 2, it's not going to tell you 3.00000. It's just going to say 3. But if you have 1.1 + 2.1, it's going to say 3.2. So it's going to, kind of use reasonable decimal logic. Radians, we just leave that there. Importantly, this function, parametric polar sequence, that will affect what Y equals looks like. We want to make sure it's on function. Again, the leftmost option is highlighted. That's what we want. As we're navigating up and down, we just hit enter to select whichever option we want. And now it looks like everything on the left is selected. I want to get out of this screen, so I'll just go, you see above mode in yellow, it says quit. So if I do second and hit the mode button, the second says I want the quit option. So if I hit second, I notice in the top right of the window, I got this little arrow. See, the arrow goes away, the arrow comes up on the top right of the window. So second mode says quit. That brings me back to my home screen. if you're ever stuck in in some window and you accidentally hit a button and you don't know how to get out of it, you hit stats by accident, you're like, oh, what do I do now? Second quit brings you back to the home screen. Okay, so now we go to y equals, and we should have a screen that looks like this. If we go to window, as a default, we want to set our window. We see Xmin, Xmax, Ymin, and Ymax. That's asking what window do we want here? Xmin, Xmax, Ymin, and Ymax. As a default, -10 to 10 on both axes usually works pretty well. So just in case, again, in case you have something kind of crazy in here, let's just go and set these from -10 to 10. This X scale we'll set to 1 so that these tick marks will be 1 unit apart. So Xmin and Xmax, -10 and 10. Note that there's a negative sign down here next to enter, but that's in the parentheses. And there's a minus sign that's the blue button that's between the times above it and the plus below it. On the TI-83, the negative sign and the minus sign are different signs. So the minus sign is a binary operator. It takes number minus number and gives you a result. So like 3 minus 2 equals 1. The negative sign applies to one digit, to one number. So -1 is allowable, but minus sign 1 will cause a problem. Right? Let me just show you that. If I do -1 and hit enter, it's like, okay, you just put in -1, whatever. If I do -1, because you see, if I try to do -1, it puts in answer, actually. But if I just went to, say, window up here and tried to put in like -1, it's not happy with that because it's expecting a first number minus second number. So be a little bit careful with that. There are some just little nuances like this that we have to be careful about. So doing -10, the white negative button, not the blue minus button, to 10 for Xmin and Xmax, X scale of 1, and then same thing for the Ys. Ymin of -10, Ymax of 10. Make sure your X or your Y scale is 1. And then this X resolution of 1, just set that to 1. That's the default setting. That works fine. Okay, so at this point, all of our calculators should pretty much be set to kind of the standard settings. So it's worth going through this once just because, like I said, sometimes if you borrow a calculator from somebody or you buy a used one, there might be all kind of wonky settings in there. At this point, we should be kind of all operating basically on the same slate. So now let's go back to y equals. One last minor point that I want to point out is if I go to this y equals screen, I see my cursor flashing. I can go down. I can go up. If I go up one more, I see that this plot 1, plot 2, plot 3 are selected. I can navigate back and forth. If I go down, I'm back into the y equals menu. So just be aware of that. These plot things have to do with statistics plots. Like if I wanted to plot a scatter plot of data, if I go up and hit enter, you'll see that now plot 1 is dark. It's selected. So the calculator will be trying to graph plot 1. Or if I do the same for, say, plot 3, go up and hit enter, it's trying to graph plot 1 and plot 3. Again, depending on who had the calculator before you, they might have used it for stats or graphing scatter plots. These might be selected, and that sometimes causes problems. So just make sure that none of these are selected. So instead of it having, 1 or 2 or 3 of them looking dark like this, any of the dark ones, just go up and hit enter on them. And you want them to all be unselected like this. You want it to be the dark letters with the light background, not vice versa. So you don't want any of your plots to look like this, because then it's going to try to graph whatever's in there. If there's something wonky in there, it'll not graph anything, it'll just get stuck. And if there's a bunch of data in there, it'll be graphing a bunch of random points all over your screen. We don't want either of those. So just make sure all of those are turned off. All right, so at this point, we should all be at kind of default settings. That's kind of an aside. There is a way that you can just like reset the whole calculator back to factory settings, but I think it's actually worthwhile going through this because this way you get a little bit familiar with stuff that can happen. You know, you might at some point during the class accidentally go up too far, hit enter, and turn on stats plot, and now you kind of know, okay, this is something that could be causing a problem, and you know, look for it if you're having trouble with your graph. So, you know, we're not just resetting the factory settings, but we're going through and setting all of the standard settings so that at least you've seen once how to do it. All right, so let's take a look at this now. Now in our calculator, when we're looking to plot a function, what it wants is it wants y equals stuff. In particular, y equals stuff with just x's. So if I want to plot, if I want to get a graph in the calculator, I need to solve my equation for y. This one's not hard to solve for y. Some others might be more complicated to solve for y, but I need to get y equals by itself, and then all of the stuff with numbers and x's on the other side. So in this case, I'm looking at y equals 2/3 x minus 5. Now I come over here and I do y equals 2 divided by 3. I always like to explicitly enter the times. I think sometimes you can get away with not entering the times and sometimes you can't. So I like to always just enter it in. 2/3 times x. It's easy to forget to put in that times sign because we omit it so often when we're writing math by hand. So that can be an easy thing to forget. And if you're getting a syntax error, if it pops up and says error, that's one thing to look at is there a place that I just wrote like 2/3x and didn't put in a times? Maybe I should put in a times to make it a little more explicit what I mean. So 2/3 x minus now, so not the negative sign, not this little white negative sign. That's kind of the smaller one, but a minus sign, the blue minus sign, 5, and hit enter. I note that the equal sign immediately next to the y1 is now darkened, where say the equal signs next to y2, y3, y4 are lighter, right? They're the dark text on the light background, where next to y1 is the light text on the dark background. That indicates that we were asking the calculator to plot what's in y1. If I had something in y2 as well, maybe I had written out an equation here, but I don't want to erase my equation. Maybe I want to use it later, but I don't want to plot it. I see I can navigate left and right in this line. I navigate left to where my cursor is on the 3, the first character. If I navigate left one more click, my cursor is on the equal sign. I see it blinking there. I hit enter. It's now unselected. My calculator will not try to graph y equals 3x plus 1 as well. I could also just clear this out, and it also won't try to graph it. So I can turn different y equals is different functions on or off this way by selecting or deselecting the equals here. I'm going to check my window. So I entered my formula. I'm going to check my window. Okay, my window is reasonable. This is usually a pretty good window to start with. And I'm just going to click graph. I get this graph here that looks pretty much like my graph over here. It's on a little bit of a different window, right? I didn't go down to -10 on my y-axis or over to +10 on my x-axis in my window when I graphed it by hand, but this looks pretty similar. I can find points on my line if I just hit the left arrow key. Oops. I need to go to trace between zoom and graph, and now hit the left and right arrow keys. I can find points on my line. Now, most of the points on my line aren't going to be super nice points, right? I see that like x equals 1.0638 and so on corresponds to y equals negative 4.29 and so on. Not super nice points. X equals 0 gives me y equals negative 5. That's a pretty nice point. But that's kind of because 0 is right in the middle of negative 10 and 10. How the TI-83 decides which points to go to, I'm not exactly sure. But if I want nice points, typically what I'll do is above graph, I see the word table. That's in yellow, so that corresponds to like a second operation. That's like almost like holding a shift key. So if I hit second graph, that will bring up a table. And I see that this table usually is typically set up pretty nicely. So I have some integer inputs for x, and then the corresponding outputs for y. I see, some of the outputs for y end up being nice numbers, like 0, -5, we found that one. Or like 3, -3, we found that one. Some of them end up being not so nice numbers, fractions and decimals and so on. Oops. And I can go up or down in my x column to see different parts of the table. If I want to manipulate how this table looks, I can go see above window. Window is where I enter kind of the parameters for what my graph looks like. If I want to enter the parameters for what the table looks like, how it behaves, I go second window for table setup. My table setup menu asks me where would I like my table to start. If I'd like it to start at 0, let's say I just put 0 in there. And then the change in table. So X with a change in table of 1 is going to go like 0, 1, 2, 3. Maybe I want a little more fineness. Maybe I'll say change in table is 0.1. I want a little more information, say close to 0. I leave these independent and dependent as automatic. So it'll automatically decide which one is the independent and dependent variable. And then second graph brings up the table, and I see now my X column goes 0, 0.1, 0.2, 0.3, and I can navigate down or up as needed. For table setup, it's usually I would start at 0 and increment by 1 unless I had some specific reason not to. This can also be kind of a fairly quick way to do several function evaluations. If I just wanted to know for several different inputs, what is my output of this equation here? 0 corresponds to -5. I can do second table set if I wanted to know if I input 7, what is my output? Just start the table at 7, go second table, and I see it's -1/3 is the output. So this is a quick way to evaluate functions. There are some slicker ways to do it in the calculator, but this is a really quick and kind of easy way to do it. Okay, so any questions on the graphing calculator? So we will pop over to the graphing calculator here and there throughout the course. We're not going to use it super extensively for most of the course. There will be some sections where we use it a little bit more than others, but for the most part, we're going to work through most of this material by hand and use the calculator as an ancillary for things like this, where I got the solution and I check and see, does this look right? So if I wanted something that looks a little more exactly like my picture, I might go into window and change my window so that, say, X max looks like it was maybe about 6 or 7 that I used here. Maybe I'll use 7. Y min was like -5. And then my top part of my y-axis from what I drew here looks about the same size as my bottom part. So I'll say y max is about 5. And then similarly, my x-axis from what I drew here, the left side looks about the same size as the right side. So I'll do -7 maybe for x min. And now I have a picture that looks almost exactly like the one that I drew over here. Right. So that's mainly what I'm going to use the calculator for throughout the course, is if I've solved the problem by hand, I might go over to the calculator to double check it, or I'll use the calculator for, its basic calculation functions. It can work just as a standard 4 or 6 function calculator, quite well. The other nice thing about the graphing calculator is you see the whole, you can see the whole calculation, and so you can double check everything a lot easier. Did I type everything in right? I see exactly what I typed in here. All right, any questions on the calculator? Any questions on 3.1 graphing linear equations of 2 variables? All right, let me switch my share over here. Okay, so moving into 3.2 now, slope of a line. So we'll start with a definition. The slope of a line is its rise divided by its run. We say rise over run. That's kind of the mnemonic that's often used to remember. What do we mean by that? We mean it's the vertical change between 2 points on the line divided by the horizontal change between those same 2 points. Or given 2 points on the line, we usually refer to points as like x comma y. But if we're dealing with 2 different points, we don't want to call them both x comma y. So we give them a subscript. This is a kind of a common practice. So if I have 2, say, x coordinates of interest, I might call one of them x1 and one of them x2. So we write this little 1 or this little 2 as a subscript. It's not something like a power. It's not like a mathematical operation we're performing. It's kind of like the name of the variable. So I guess I could say, like, I could instead call this like W and this like V or something. But if I call it W and V, I might forget, like, does this correspond to X coordinates or Y coordinates? If I call it X1 and X2, it's a little easier for me to remember, okay, these are X coordinates. And in particular, this is the X coordinate that goes with whatever point I've decided to call point 1. So I know it goes with the Y coordinate, Y1, that's for that same point. So there's a good reason for labeling them this way. But in theory, there's no difference if I call them W and V or something like that instead of X1 and X2. That would be the same thing in theory. Just a little harder for me to remember and keep straight what's what. Some people call it X sub 1 and X sub 2. Nothing wrong with that, like sub being a shortened version of subscript. I usually just say X1, X2, and so on. That's rarely ambiguous with any other mathematical term. So if we have 2 points on the line, point number 1, x1 comma y1, and point number 2, x2 comma y2, then the slope of the line is defined to be, again, the rise over the run, the vertical change, the change going from y1 to y2, that's y2 minus y1, divided by the horizontal change, the change going from x1 to x2, that's x2 minus x1. Note that if we swap the 2 points, we interchange the order in the numerator, and also in the denominator. This is the same slope. Why is it the same slope? Well, I can factor a -1 out of the top. And out of the bottom. And those -1s divide out. So it's not super important which point I call point 1 and which point I call point 2. It is super important that I stay consistent. If I say this point is point 1 and this point is point 2, the point 1 has to have x1 and y1, point 2 has to have x2 and y2. I can't, like, if I did say y2 minus y1 over x1 minus x2, that would be wrong. I would end up getting negative the result that I want to get. So as long as I'm consistent, it doesn't matter which one I label point 1 or point 2. We're just taking the difference in y values over the difference in x values, but staying consistent with which one's first and second. Okay, so let's take a look at these two graphs. Let me blow these up a little bit so you can see them a little better on your screen. We want to compute the slopes of these lines. So one thing is, when I'm given a graph like this, I kind of have to make an assumption that if it looks like the line goes through, say, an integer point, like this, maybe 4, 1, I'm going to assume that it actually does. Oh, I turned that into a little square. I'm going to assume that it actually does go through 4. Jeez, can't draw a circle without OneNote trying to make a square. I'm going to assume that goes through 4, 1. Can I tell that for certain from the graph? No, it might go through 4.01, 0.99. But, if we're told compute the slope of the lines, just given a graph, this is a pretty reasonable assumption to make. So I'm going to assume that one point on the line is x equals 4, y equals 1. And if I look along this line, I mean, there's, maybe something here. It looks like maybe 5, 2.5. That's not really the crosshair. I'm going to look for intersections with crosshairs with integer points. I see another one up here. OneNote really does not want me to draw a point here. There we go. I see another intersection with the crosshairs up here at 6, 4. Now, it doesn't much matter which one I choose to be point 1 and which one point 2. Up here, I'm going to do the 2's minus the 1's. I'm going to choose point 2 to be the one that's easier to subtract point 1 from. In other words, I'll consider this to be x2, y2, and this to be x1, y1, just because it makes my life a little easier. If you did it the other way, no big deal. But I'm doing this because if I do 6 minus 4, that's a positive number. 4 minus 1 is a positive number. That makes things a little easier. My slope then, which I give the name m, when we see m, that typically denotes the slope of the line. It's the rise over the run. It's the difference in the y values, 4 minus 1, so going in this direction, divided by the difference in the x value, 6 minus 4. Again, if you had labeled point 1 and point 2 the opposite way, and you got 1 minus 4 divided by 4 minus 6, you'd get the same answer. The negatives would cancel, as long as you're consistent. You can't do 4 minus 1 over 4 minus 6 and get the same answer. You would get negative of the correct answer. But 4 minus 1 is 3. 6 minus 4 is 2. This is a slope of 3/2. We know this slope represents rise over run, or sometimes we write it as change in y over change in x. What does this 3/2 represent? It says for every 1 unit we go to the right in x, we go up 3/2 units in y. Or for every 2 units we go to the right in the x direction, we go up 3 units in the y direction. Or if I think I'm climbing a hill that has slope 3/2, for every 2 units I move horizontally, I move up 3 units vertically. If I go 2 feet forwards, I go up 3 feet. We'll do the same thing with the line down here. Now, if I look at this, I do see a couple of different points. You know, -3, it looks like, 3, 1, it looks like, but one thing that can be really easy to deal with is intercepts. So where the line intersects the x-axis or the y-axis. So the intersection with a C of the line with one of the major axes is called an intercept with a P. So a little hard to hear the difference in that sometimes. But if I look at my y-intercept, that's where the line intersects the y-axis. I see that's at this point. That's at the point 0, 2. Now, sometimes we have nice intercepts like this one here, say 0, -5. We could have used that intercept at that point just as well up here to find our slope. Sometimes we have, say, like this x-intercept that I'm not really sure what it is, right? It doesn't quite look like 3.5, but it's certainly not 3 or 4. So sometimes these are nice to use. They end up pretty nice. Sometimes they're not so nice to use. But if they're nice numbers, then they're often good ones to use because 0 is typically a very easy number to use in arithmetic operations. And similarly, my x-intercept, where the line intersects the x-axis, that ends up being a nice number as well. When x is 6, y is 0. And I guess I'll call this x1, y1, and this x2, y2. Again, if you label them the other way, not a problem. If you use, 3, 1, or if you use -3, 3, or -6, 4, all also valid points to use for this. I picked the intercepts because of the zeros. That makes my arithmetic a little bit easier to do, but it's not wrong to use any of these other points. Again, as long as you're consistent with, which one is the 2 and which one's the 1, which one it comes first and which one's subtracted off of that. My slope is the difference in the y's, so 0 minus 2. So going left to right, I'm going down, I'm losing height, so my rise is negative. And my run, again, the 2's minus the 1's, 6 minus 0. This gives me -2 over 6, or -1/3. I see that a positive slope, as I go left to right, I gain height, I increase in the vertical direction. And a negative slope, as I go left to right, as I increase in the horizontal direction, I decrease in the vertical direction. A positive slope means the two variables kind of go in the same direction. When one increases, the other increases, and vice versa. A negative slope means they go in opposite directions. When one variable increases, the other decreases. Any questions so far? Okay, what's the slope of a horizontal line? If I have some set of axes and I have a horizontal line, this has the same y value regardless of the x value. So the points on this line look like, say, x1 comma h, let's call it, for height, and x2 comma h, We have the same height, so to speak, no matter what. Well, my slope is rise over run. It's the vertical change divided by the horizontal change, or it's h minus h over x2 minus x1. As long as I didn't pick the same x coordinate for both, if I didn't just pick the same point twice, I see that I get 0 over some number that's not 0. This is a slope of 0. That's also consistent with our interpretation before, that if I imagine walking along a hill of slope 2/3 or negative 1/3 or whatever, if I go, say, 1 foot horizontal, I gained 2/3 of a foot vertical in the first example. Here, if I'm walking along flat ground, if I go 1 foot or 2 feet or a mile horizontal, I gain no vertical height, and I don't lose any vertical height either. So the slope of a horizontal line is 0. What about the slope of a vertical line? Oh, let me draw my axes in black. Well, now if I pick two numbers, 2 points in the line, two numbers for y, the corresponding x is the same. So I have something like, let's call it d for maybe distance. The x coordinate is the same for both of these. So d comma y1 and d comma y2. So this x coordinate is d. Now what is m? Well, it's the rise. It's y2 minus y1 over the run, d minus d. Or this is some number that, as long as we didn't choose the same point twice, if we choose two different points, we get a non-zero number divided by 0. If I have a straight up and down wall, I can't walk forward along the wall. This is undefined. So vertical line is a special case where we have an undefined slope. It's kind of, in some sense, a little bit like an infinite slope. It's like if my wall was really steep and it was really hard for me to walk up, if I wanted to move 1 foot forward, I'd have to go 1,000 feet, up. And then it gets a little steeper. 1 foot forward, I have to go 1,000,000 feet up. And then even steeper. That's kind of what's happening. It's the point where to go 1 foot forward, I need to go what looks like it's going to infinitely many feet in the vertical direction. So our slope is undefined for a vertical line. All right, what's the slope of the line passing through 2 points? If I'm given the 2 points, how do I compute slope? Well, I just label them. Let me call this point 1 and this point 2. So I have y2 minus y1, -2 minus a -6 over x2 minus x1 over 2 minus 3. So I have -2 plus 6 over -1, or that's -4. Does this make sense from a picture? 1, 2, 3, comma -6 is something like that. And 2 comma -2 is something like that. Yeah, that's a negative slope. And it looks like it's pretty steep. I mean, my axes are a little off. My x-axis is a little more spread out than my y-axis, but I did this pretty quickly and it looks pretty reasonable. It looks like that could be a slope of -4. If I had ended up with something like this, I would suspect I've made a mistake somewhere. Okay, what if we want to graph a line using a point and a slope? So graph a line through the point 1 comma 4 with slope of negative 1/2. So this is my point of interest, 1 comma 4. Now, if the slope is negative 1/2, I know that I'm going to be going downwards like this, not upwards like that. And I know that for each 1 unit I go to the right, I'm going to go down half a unit. Or for each 2 units I go to the right, I'm going to go down 1 unit. So I'm going to go through 3 comma 3. And if I go 2 more units to the right, I'm going to go down 1 more unit, 5 comma 2. And there's my line. I don't have to figure out what the points are explicitly. I did here just so I could kind of say them to you. But I could just use the slope and know that if I go 2 units to the right, I go down 1 unit. If I increase my horizontal distance by 2, I have to decrease because of the negative my vertical distance by 1. So I can just use that slope. That kind of tells me the direction to head from that initial point. And I have a couple other points that I found on the line. Everything looks good. So let's take a look at this equation of a line, figure out what is the slope and what is the intercept, and draw a graph. And when we just say the intercept, typically we mean the y-intercept in this context, in the context of graphing lines. If we want to say the x-intercept, we'll typically be clear about that. So the y-intercept, remember, is where we intersect the y-axis. That's when x is 0. So my y-intercept is when x is 0. I have negative 4y equals 8. Y is negative 2. That's my intercept. That's also a point on the line. If I want to find the slope, well, I could use slope-intercept form, which we'll see in a minute here. I could put it into kind of a standard form and then figure out what my slope is based on just looking at that form. But at this point, we haven't introduced that concept. We'll just find slope the old way. We'll pick a different we'll pick a different x value to use to get a second point. So if I try to pick y equals 0, I get like 3x equals 8, x equals 8/3. That's not a very nice number to deal with. But if I pick, say, x equals, I don't know, 1, well, x equals 1 gives me what? It's going to give me 8 minus 3 is 5. 5 over negative 4, that's not super nice either. If I pick, maybe if I pick, say, something like x equals 4, I get 12 on the left side. 8 minus 12 is negative 4. I think that's going to work out pretty nicely. So sometimes we have a little bit of trial and error to decide what value of x or y we should pick to get something that works out kind of nicely. But this gives me 3 times 4 minus 4y equals 8. Or move the 12 to the other side, I get negative 4y equals negative 4, or y equals 1. So 4 comma 1 would be a good second point to use. Again, nothing inherently wrong with those other 2 points that I was discussing, but there's fractions. I don't really want to deal with a fraction in the numerator or denominator of another fraction. That's just more error prone, more places for me to make a mistake in the arithmetic. I'll pick an easier point to deal with instead. And I'll call this point 1 and this point 2, just to stay consistent with which one I'm subtracting from which one. So the rise, 1 minus a negative 2 over the run, 4 minus 0. 1 plus 2 is 3 over 4. My slope is 3/4. Any questions so far?
I do. I have one.
Yeah.
Sorry, I missed how we got the 0 and a -2. How do we get
Yeah,
that?
sure. So the y-intercept is, if we have the line, whatever it looks like, it might not look like this. But it's the intersection of the line with the y-axis. So that's what it's defined to be. It's the point where the line intersects the y-axis. Now, if we're intersecting the y-axis, that means that that point is always going to have an x-coordinate of 0, because that's what places it horizontally on the y-axis. And then we have to figure out what is the y value that's associated with an x value of 0. When I plug in x equals 0, 3x is 0. And then I'm left with negative 4y equals 8. Divide through by -4, and I get y equals -2. And that's where that piece comes from.
Okay.
Yep. So the
I
x
get it.
equals 0 comes from the fact that y-intercept always has an x-coordinate of 0. And the y equals -2 comes from the equation.
Equation.
X equals
Okay.
0, figure out what y is.
Thank you.
Yeah, sure. Yeah, good question. And one little technical note is the y-intercept is this point, 0, -2. It's not the number -2. A lot of people will just write the number -2, but it really is the whole point, 0, -2. That ordered pair is the y-intercept. It's the point of intersection, not just the y value of that point. Yeah, good question. Okay, so we are about out of time for today. When we come back next week, we'll talk about the slope-intercept form of the equation, which is another way to approach something like this and find the slope just off the basis of this algebraic equation. And then we'll talk about parallel and perpendicular lines and move on from there. So.